In this video, I'm going to give you a couple vocabulary words to fill in, and then I'm going to show you what I'm going to use those vocabulary words for in terms of these two real-world situations for linear applications. Now, the first blank here we're going to put in is going to be linear equation. Now, a linear equation is a linear function, and it is going to be used to model real life situations. And your slope, so that's this blank here, the slope is also called the rate of change. It's the changes of the y values divided by the changes of x values. And your y-intercept is your initial starting amount. So I'm going to put start here. Now, for this example A, for number 4, so part A of number 4, and then I'm going to do B, we have a telephone company that charges 25 cents for the first minute and then 15 cents for each additional minute. Write a linear equation that models the cost of the telephone call. So my rate of change is going to be when you see the word each or the word per. And we do see the word each additional minute. So 15 cents is going to be per additional minute after a starting point of your first minute, which is going to be 0.25. So my function of x would be 0.15 per additional minute after the first 25 cents for the first minute. Now, f of x could also be written as y equals 0.15x plus 0.25. So f of x, you could replace this whole thing with y. So this is stating what my function is. Then it says use the linear model to determine the cost of a 10-minute call. Now 10 minutes is what I'm going to put in because my slope here is per additional minute. So per minute I want to put in here. So f of 10 minutes is going to be when I substitute 10 in for x. So 0.15 times 10 and then plus 0.25. Now you can use your calculator here, or if you know your decimals, if I multiply this by 10, my decimal point's going to go up one place to the right. So that'll be $1.50 plus 25 cents. And if I add that all up together, the cost, $1.50 plus 25 cents, would be $1.75 for that 10-minute call. Now in example B, it says that you have a car rental company, and that charges $25 for a rental car. And then there is an additional 20 cents per mile charge. So that gives me my clue that this one is going to be my slope. So 20 cents per mile. And my starting fee, they charge you $25 for your initial fee. Sometimes you'll pay taxes and fees, and normally that's actually a lot more than $25, so this sounds like a really good deal, but that would be for this scenario. So f of x, my function is 20 cents per mile, and then plus initial charge of $25. We could rewrite this as y equals, so y is equal to 0.20x plus $25. Now it says, use the linear model to determine the cost if the car is driven 75 miles. So per mile, I'm going to plug 75 in for my x. So the function evaluated for 75 miles, again, plugging that in for x, would be 0.20 times 75 and then plus 25. Now for this one, I am going to need my calculator. So let me grab that real quick. And I'm going to type this in. So clear out what I have, 0.20 times, in parentheses, 75 miles, and then plus 25, I get a solution of 40. So this is equal to $40. And then, if the final cost was $31, how many miles was the car driven? So if my function of x was equal to $31, solve for x, which is my miles. So I'm going to set 31 equal to 0.20 per mile, because I know I'm solving for miles and my x was miles, plus that $25 fee. Subtract the $25 fee, and you'll be left with $6 is how much you have to count for how many miles you went. So $6 divided by 20 cents would be 30 miles. Now the next two are for your own practice, and if you want to, try them out and then check the key on my Canvas page.